I'm Quasar, and welcome to Quasar Does Astronomy. Today, we will be looking at Flat Earther CC, who doesn't believe that water can stick to a ball. So, what we're going to do in this video is attempt to educate CC on what he got wrong, and hopefully have a little fun doing it.
Good morning, good evening, good afternoon, wherever you may be. CC here, Chris, from New York, Westchester County.
Well, it's afternoon here, so good afternoon. Quasar here, Illinois, Cook County, 1060 West Addison Street.
You know, I kind of like the Wrigley Field fit.
Yeah, real cute.
That's why I always hated Memorial Day weekend, you know. It signifies the end of the summer. And that's what, you know, that's how the media portrays summer.
Wait, I thought this video was about water.
But let's look at water. I want you to look at water for a minute.
Finally, we can get to the point.
When we were in high school, the scientists wanted us to believe that this planet is just big enough that it breaks the laws of gravity, right?
I don't think you know what you're talking about.
That's gravity, the gravity that we've learned in school. That's supposed to hold everything on the planet itself, right? So nothing flies off into space.
Yes.
So our planet apparently is just big enough where it could completely break the laws of physics with water, where it bends and contours to the planet.
Liquid water forms a shape based on the forces acting on it. In fact, there's a fun little experiment you can do in your own home with a faucet, your hair, and a comb. Let me explain. Water is a polar molecule, stemming from the polar covalent bond between the two hydrogens and the oxygen. Basically, this bond means that two electrons are being shared between the oxygen and the hydrogens. So, in the case of this polar covalent bond, the oxygen has a slightly negative charge, and the hydrogen has a slightly positive charge. So, when I turn the faucet on, I want to make the water run in as thin a line as possible, without it just dripping out of the faucet. What I'll do then is rub the comb against my hair, creating a negative electrostatic charge on the comb. Now, placing the comb next to the stream of water, the water will pull towards the comb and you'll see a bend in the water. Let's go try it out.
Hi, so I took a trip down to my bathroom in order to show you the experiment with the water in the comb. So the first thing we're going to need to do is we're going to need to turn on the water. And remember, we want as thin a drop of water as possible without it actually dropping out of the faucet. Alright, that looks pretty good. So we'll go ahead and take the comb, and I'm going to rub it in my hair for a bit. So we're just going to sit here, rub the comb in my hair, get as much of a charge on there as we can so that it'll be nice and obvious. And now that we've got a charge on the comb, we're going to take it and we're going to put it next to the water. So we can see the water is bending towards the comb. I'm going to take it away, no bend. When I put it up close, bend. So there, we've shown that water will conform to the forces that are acting on it. Alright, let's get back to the video.
Well, when we're out in space, we look back onto Earth and it's this perfectly round ball. It's perfect.
Well, technically speaking, the Earth is an oblate spheroid. It means that the bottom half of the Earth is a little bit thicker than the top. However, the difference is so minute in comparison to the size of the Earth that you can't tell with the naked eye.
Well, what about Titus? Is it Titus or Titan or what?
It's pronounced Titan.
But I think it's on Saturn or... Yeah, I think it's on Saturn. Saturn or Jupiter, whichever one. It's a watery planet. It's like a frozen planet. But I guess, you know, that's really small. Much smaller than the Earth. But ice seems to bend there, too.
So, Titan is the second largest moon in our solar system to Ganymede, one of the Galilean moons of Jupiter. Titan orbits Saturn and was discovered in 1655 by Christian Huygens. Titan, with its nitrogen atmosphere and icy surface, is one of the more interesting bodies in our solar system, and is referenced in many different forms of entertainment.
So, if we were a planet, and all of this water with all of this weight, wouldn't it be going downhill too? And it would just slosh right off the planet? Oh, it doesn't make any sense because we don't live on a planet. It's unbelievable. It's that simple. You see, that's the thing with flat Earth, that it's very easy to figure this out.
Okay, CC. For someone who dismisses gravity, you really don't have an understanding of what scientists claim gravity does. In the globe Earth model, down refers to the center of the core of the Earth. At all places, down points inward. So I'm going to grab a ball over here. It's not a baseball, but this is what I could find. It's kind of oddly shaped. However, I did get it at a baseball game, so it still counts. So let's say that this ball represents the Earth. Now, for the sake of argument, let's say that there's a very thin layer of water covering the entire surface of this ball. Physics tells us that the water would be pulled towards the center of this ball at any point around this ball. Water would be pulled towards the center of it. You state that water should fall off the bottom of the Earth. In space, with which Earth resides in, there is no true up or down. For the sake of argument here, we'll assume that you're referring to the southern hemisphere as the bottom of Earth. In order for what you have asserted to occur, a much more massive object than the Earth must exist below Earth. However, we can easily disprove this, as no such observation has ever been made in the history of time.
I mean, it's just, it's that easy. You know, that's how easy it is to describe to somebody flat Earth. So they can understand it in a totally different way than they've been brought up to, where it's complicated and nobody understands it, and everything in the solar system is got this certain type of Goldilocks position where it shouldn't exist, and it never, because it doesn't.
So, first off, just because something is complex doesn't mean it doesn't exist. The human body is a very complex machine. A computer, a very complex machine. Complex things exist. I mean, I'm recording this video on a webcam, which I will then edit, put together, and then upload to YouTube through the internet. Things are complex. This happens. Secondly, you brought up the Goldilocks position in regards to space. I'm going to take a leap here and assume you're talking about the Goldilocks zone. This is an astronomy term we use and has nothing to do with whether something should exist or not. It simply references the location in a solar system, not necessarily our own, where, due to the star's energy output, the planet would not be too hot or too cold to support life as we know it. Now, CC kind of derails here from Flat Earth for the next minute or so on a topic that I'm not going to go into. If you want to view the full video from CC, the full video will be linked below in the description. But, like I said, I'm not going to get into it, and if you want to view it, go watch the video. We'll pick back up when he starts talking about the Flat Earth again.
Okay, the agenda that they want to do with the aliens. Yeah, well, here they are, okay? They've already said that they've managed to get some sort of transmission out in space, billions of miles away or millions of miles away, or this light.
I believe here CC is talking about FRB, which refers to fast radio bursts. One of the many possible explanations of this phenomenon is aliens. However, this explanation does not appear to be the leading theory. In my research, I found an article that should help explain FRBs from National Geographic, and the link will be in the description below. So, I'm going to go ahead and wrap up here. Cece goes on to make a few other claims, but they're not related to Flat Earth, so we won't cover them in this video. Again, if you want to see the whole video, it'll be linked in the description below. I'm Quasar, and this has been Quasar Does Astronomy. Keep learning!